This is a demonstration of how I would solve the findMinIndex problem in exam number 2. So let me just go ahead and first unzip the zip file, go into the folder, and what I would do is I'm gonna go copy the entire C code into the assembly code and then insert the comment symbol in front of every single line. So this is starting from line 6 to line 19. So 6 to 19 yank and switch to the other file and just paste here and give each line a pound symbol so they're all comments. Alright, so at this point I am ready to really write the program. Before we do that, we have to first define all the constants for various items on the stack. We start with old EBP and then return address, and then we have array, which is a pointer, and finally we have the size, or the number of elements in the array, like so. After that, we specify the entry point instructions: push EBP, move EBP to ESP, whoops, the other way around, move ESP to EBP. That's important. And then the exit code would be the reverse of that, so we move EBP back to ESP and then pop EBP followed by the return instruction. Alright, so inside the subroutine we have a few local variables in the C version, and we want to see whether those are actually necessary. One is minIndex, which keeps track of the index of the minimum element, and the other one is I, which basically just goes through the entire array. For this particular code, it is very handy to have the base scaled index addressing mode. We do need to keep an array in a register to do that. MinIndex has to be in one of the registers, and I has to be in another register. So in order to do that, we will use up a lot of registers, but that's okay. We want to use EAX for minIndex because we're supposed to return minIndex as our result anyway, so it makes sense to use EAX for minIndex. So knowing that, we go here and then we move a 0 into EAX and then just comment and say EAX is our minIndex. Next, we can specify which one to be I. I'll just pick EBX to be I. And now we are ready to implement the loop here. To implement the loop, the first thing we need to do is to perform the comparison. Now that both I and size are in, both I is in a register, it's easy to compare that to size. So we say compare long size paren EBP, because size is still a parameter that is pushed on the stack. And then we compare that to I, but remember I is EBX, so we compare that to EBX. If I is greater than or equal to size, we get out. So the other way to say it is if I is not less than, so J and B jump if not below. If I is not below size, we get out of the loop. And I immediately go to the exit point of the loop to specify the exit loop label. And also, right before we get out of the loop, we also have to remember to perform an unconditional branch back to the beginning part of the loop. And this is the beginning part of the loop. So you can see that I don't really write the program in a linear fashion. I jump around because I want to deal with the structure one thing at a time in a nested fashion. Okay, so now that the control loop, the control part of the control structure of the loop is handled, we can specify what is inside the loop here. if array min index is greater than array I, so that means we need another register to keep track of array, which is a pointer to the first element of the entire array. We can do the initialization here. We can use ECX for that purpose. So we can say move array EBP to ECX, and then write down some comment here to say ECX is array. Now this step is necessary because in order to use the base scaled addressing mode, the pointer to the base of the whole thing has to be in a register. So we have no choice but to perform this step. Alright, so now that we have everything in place, the comparison of array min index against array bracket I is relatively easy. Okay, so once again we are comparing long. Array bracket I is using the base scaled index addressing mode. Well, this is going to be a two memory operand. We cannot do that, so we have to move one of them into a register first, and luckily we do have one register left, which is EDX. So we move one of them into EDX. Doesn't matter really which one we move into EDX. We'll move array min index into EDX. So we say move long, use the base scaled index addressing mode. Array is %ECX, and min index is EAX, and the scale is 4. So that's our addressing mode. We put it into EDX, and then we can compare array bracket I to EDX. So that would be ECX, which is our array, EBX, which is I, a scale of 4, and then compare that to EDX. The conditional statement says if min index is greater, if array bracket in min index is greater than array bracket I, we perform the following statement. So that means if it is not greater than, we have to branch around. So in this case, we say jump if not greater than, okay, JNG to end of the conditional statement, and we immediately write down where that label is supposed to go. And then inside here we simply want to copy I to min index, so we can do that with one single instruction, which is move L. In this case I is in EBX and min index is in EAX, so that would copy that. We just have one more thing to do before we hit the bottom end of the loop, which is to increment I. I is already in EBX, so adding 1 to EBX will add 1 to I. We don't really need to do anything about return min index because the answer is already in EAX when this is all done. So this is findMinIndex implemented in assembly, so we want to see whether that works or not. So we say make main.out, see if we have any no syntax errors, and then we want to figure out whether it actually works or not, and it does work amazingly the first time.